So, hello everyone, myself Nitish. So, today's we are going to presentation on one topic, static characteristics of IGBT. Subject is power electronics. So, next slide, the symbols of IGBT. The IGBT means IGBT is also insulated gate bipolar transistor. The IGBT is mainly three terminals. One is a gate, second collector, and third is emitter. The collector is also known as drain and emitter is also known as source. In a p-channel IGBT, the directions of the uh, when the by reversed in shown in the figure. So next slide, construction of IGBT. The construction of IGBT, the basic structure of IGBT. This is the main structure of IGBT. The main the main difference between the structure of MOSFET and IGBT is the existence of the P plus junction layer, which frame forms the collection of IGBT. The IGBT structure contained PN-PN thyristor structure between the collector and emitter terminals. The N plus buffer layer between the P plus drain the P plus drain content and the operation of the IGBT. The IGBT is switch buffer layer are termed as the punch through the IGBT, whereas the IGBT is without buffer layer are terms as non-punch thyristor as NPT IGBTs. So next is classification of IGBTs. The classification, there are two types of IGBTs. First is a symmetrical IGBTs and second is asymmetrical IGBTs. Asymmetrical IGBTs is also known as non-punch thyristor IGBTs and asymmetrical IGBTs are also punch thyristor IGBTs. So this is figure shown in below in forward blocking IGBT and reverse blocking IGBTs. Forward blocking IGBTs are we see supplier as a forward and the reverse blocking IGBT as the uh, we see as the positive or negative supply as a reverse supply are there. So this so this is the figure in forward bias and reverse bias. So first is a forward blocking IGBT, a standard insulated gate bipolar transistor designed to block high voltage in the forward directions but has limited or on capability to block the reverse voltage. Okay, uh, at requires requires an external diodes from reverse voltage protection in AC applications. When the extra diodes are required in the protection of AC application voltage protection of AC applications, then reverse blocking IGBT, the uh, modified IGBT that can be block voltage in both forward and reverse direction without needed an external diode, and the design by removing the N plus buffer layer, allowing the reverse blocking capability. The main difference of the forward IGBT and reverse by blocking IGBT. The blocking IGBT can block the voltage only in forward direction. While reverse blocking IGBT can block voltage in both forward and reverse direction. So reverse blocking IGBT is used in bidirectional power applications like matrix converters, when forward IGBT is used in unidirectional applications like motor driver and inverters. So next, output characteristics of IGBT. The output characteristics of IGBT, there are x-axis has a collector emitter voltage and y-axis collector current collector current. The output characteristics of insulated gate bipolar transistor shown in the relationship between the collector emitter voltage VCE and collector current IC from the different gate emitter voltage VGE. When the graphical representation, the output characteristics of consist of three regions, and the typically plotted as a family of the curves from different value of VGE. There are three regions. First is a cutoff regions. When VGE is greater than IGBT is VGE is greater than IGBT is off, and IC is equal to 0 if the VCE is increases. Then next is a region is active region. Active region, when VGE is small, then IGBT is turned on. Then third region is forward blocking, when VCE is high but VGE is insufficient, the IGBT is off and blocks forward voltage. So next is transfer characteristics of IGBT. Transfer characteristics of IGBT. The transfer characteristics of an insulated gate bipolar transistor shown in the relationship between the collector current IC and gate emitter voltage VGE at the fixed collector emitter voltage VCE. When the x-axis as gate emitter voltage VGE and y-axis collector current IC. There are also three regions. One is a cutoff region. IGBT is also off when VG is greater than threshold voltage. The IGBT is remains off. No current collect in current. When then second region active region, and IC increases exponential with the VG initially. Then and third region is linear region. Then after the initial rise IC increases linearly with the VGE. So thank you.